We're studying IGCSE chemistry and we're starting extraction of metals too. To recap, in the last class, we looked at extraction of iron. In today's class, we're going to talk about the agenda or the objective. I like the word agenda rather than objective. Is to finish extraction of aluminium from bauxite. And that's it. And we have galvanization. Well, rust prevention. Now get your books open, go to chapter number 16 and tell me when you're there.
Good evening, sir.
Good evening, Diana. Assalamu alaikum. Welcome to class. Now, were you there in the last class for chemistry? I think you were.
Yes, sir.
Do you remember what you did? Recap, tell me. I'm opening the book for you, just a second. Guys, can you see the book?
No, sir.
Yes, sir.
Diana can see it. Well, I cannot. It's loading. But this is your book, right? That's good. Fine. Let's start. Okay. We read chapter number 16, which is page number 309. Now we're starting extraction of aluminium right here from its ore, which is called bauxite. Safa, start reading from here.
Sir, I can't see the book.
You can't see the book? All right. Now can you see the book?
Yes, sir.
Start reading.
Extraction of aluminium from its ore. We have seen that reduction is with carbon does not work for more reactive metals. The metals are held in their compounds, oxides or chlorides, by stronger bonds that
yes.
a lot of energy to break them. This energy is best supplied by electricity. Extracting metals in this way is a three-stage process.
Three.
Mining the
Now
ore.
stop. Lula, continue.
Melting the ore, purification of the ore, electrolysis of the molten ore.
All right. So you mine the ore, you purify the ore, you electrolyze the ore. Three-step process. Now look at this. This is called bauxite. What is it called? Bauxite. The box from the boxing match, and it's called bauxite. Something like that. And this is the ore of what? Of aluminium. Like hematite is the ore of iron. This is the ore of aluminium. Al. Any questions?
No.
So,
First thing first is we're going to get the bauxite out of the ground, and it has a few impurities. We'll look at that in a second. Now look at the whiteboard. Okay, can you see the whiteboard?
No, sir.
No. Now.
No. Okay. Yes. Now
Yes.
we can see. Yeah.
Now you can see. Now, first thing first you have to do is now, guys, do you know what electrolysis is? Do you know what electrolysis is?
I don't, sir.
I'll tell you electrolysis. The electrolysis is write in your notebook. Breakdown, the definition, breakdown of chemicals, of compounds using electricity. There's no way you can understand this chapter without knowing this. So I'm just recapping from a previous chapter so you understand. Chapter 6. You should know this is chapter 6. You can study it on your own and ask me for doubts later. Now, when you're done writing the definition, tell me. You have two things, cathode and anode. Cathode is called the negative electrode, and anode is the positive electrode. The reduction takes place, oxidation takes place. Metals go here, non-metals go here. Example is could be, let's say a metal could be anything. Two example, I'll give you two. Just a second. Write one reduction of positive cations. Happens. And oxidation of negative anions happens. Now, one example of this could be H plus E minus gives us H, or 2H plus 2 electron gives us H2 gas. The second thing is could be, let's say, Diana, name any metal. Quick.
Iron.
Iron. So Fe, iron 3 plus 3 electron will give us Fe. I'll give you the state symbols over here as well. Well, that's all you need to know right now. Don't worry. Just write gas over here and solid over here. And this is aqueous. This is also aqueous. Write this down. Tell me when you're done. And make this diagram as well. It looks like a happy face. It's actually a tank used for electrolysis. This is what the electrolysis tank looks like. Something like this. Perhaps some solution inside it. And what happens is something blue will go up from here. Let's make this negative. Positive, negative.
So should we draw this diagram?
You should draw the diagram, yes. And yes, you should draw the diagram. As a rough sketch, try your best attempt. But don't draw it right now. Have you finished writing this?
So
Okay. Lula, Diana, have you finished writing all of this?
Yes.
Now write one more thing here. Example. For anode is going to be Cl minus, loses electron, so it's oxidation, loss of electron. This is what it looks like. Another example could be, let's say, another example could be another non-metal. Let's take, perhaps you can take oxygen, or I can take OH minus. Now write both of these equations. This is a whole chapter, but I'm trying to just brief it down so you understand what's going to happen after this. Quick.
sure, is it 112 or is it hydrogen?
Where this one?
In the example. Yeah.
Where this one? That is hydrogen.
No, up here. In the first example, it's
This?
there in the anode example. In the first example of anode.
Anion. This one?
On your left.
On my left. This one?
Yeah, this one. This is hydrogen, right?
It's not it's chlorine, Cl.
No, sir, this 112.
Okay. This one? Oh, that's nothing. That's not hydrogen. That's basically one. First equation. Okay. And second equation. This is one. Fine.
Yes.
First example, second example. Like over here.
That's all.
So, Lula, how much? Safa?
Done, sir.
I'm just
Done.
drawing.
Now you don't have to draw the diagram. No.
So, okay.
Okay. Well, if you have drawn it, then don't cut it out. Just leave it like that. We'll talk about that later. Now, all you need to realize is, if I had, let's say, if I have a solution, okay, let's remove all of this for now. If I have a solution, which looks like this, give me 1 second, like this, and I had a solution here. In this solution, I have two things, Na plus and Cl minus. This is molten. Now, this thing right here is called, all right, just write one more thing here. After compound, write in brackets, write electrolyte. Fine. Breakdown of compounds, put brackets, electrolyte. This is called electrolyte. Now, when you have done that as well, I want you to make this diagram, the one in front of you, and just make this. Over here we have electrolyte. Let's say make an arrow like this and put electrolyte, and this is power supply. This these are electrode. Let's say these electrode, and in front of electrode write carbon, comma, platinum. Or don't write that. Let's just let it be as a lecture. And that's it. This right here is cathode, the negative one, and the positive one is anode. Now tell me when you're done. Now, like I was telling the other people, the other student in the last class, that he is behind and he has to work harder than the rest. That is also true for all of you. I don't think you guys are bad or dumb or stupid. The only issue here is that you guys are you need a lot more practice, and there's a lot more you have to study, and you have to work much harder than other people. That doesn't give you a disadvantage. That only tells you that, okay, this is my situation, and this is what I can do to get the marks I want. Is that clear, all of you?
Yes, sir.
Yes, sir.
Now finish making the diagram. Tell me when you're done.
Done.
Diana,
Yes, sir.
all right. Then, okay. Now I'll just give you one question. One question on this from electrolysis. If I have a beaker like this, not a beaker, it's a container, and I have my electrodes again, and I have my power supply. This is positive, this is negative, positive, negative. I'm going to call this A and I'm going to call this B. Fine. Now your job is to tell me if I have electrolyte, if this electrolyte here, electrolyte, is molten NaCl, okay? Which basically means the ions inside it are Na plus and Cl minus. Is that clear? If I break NaCl, what will I get? Na is group 1, so it's always going to be positive. Positive 1. And Cl is group number 7, it will always be minus. So these are the ions I have. From my electrolyte, I get these ions. Now, can you tell me where will Na plus go? Will it go to first electrode or the second electrode, A or B? Where will Na plus go? Let's give your answers in the chat, all 4 of you. So give the answer in the chat. Where will the electrode go? Where will Na plus go? Which electrode? A or B? Anode, which is A, or cathode, which is B? Think about it. Give me any answer. If you don't know the answer, say I don't know. Though that is also a valid answer. So I've gotten one answer. The others tell me. Okay. Got it. I've gotten 2 answers. All right. I've gotten a lot of answers. One person is remaining. I've got all the answers. Everyone is correct. Good job. So Na will go to this one, and Safa went one step further and told me that Cl will go here. That is correct. Any questions, anyone? Plus goes to minus, minus goes to plus, right?
Yes.
Yes.
Now that is the basic introduction you need for electrolysis. Rest of it, we'll do it on electrolysis chapter. Let's go back to extraction of aluminium. Extraction of aluminium. Now in this, what we have to look at is, first let's start with the ore. The ore is called bauxite. Perfect. Now next thing we have to look at is, what are the steps here? Let's say process. Step 1. step 1 is aluminium 3 oxide is dissolved in molten cryolite. Na3Al6. This lowers boiling point, melting point. Over bauxite, then after bauxite also, right, has very high melting point. Now step 2 is okay, just a second, something is missing. This is step 2. Step 1 is going to be bauxite is treated with sodium hydroxide to get alumina. Reason saves energy costs by lowering and saves energy costs as less energy needed. Third step, another step is
Sir,
yes,
is sodium a good conductor of heat?
sodium is a metal, so it's a good conductor of heat. But that's not, you don't need to think about this. Ask me if you need to know why the temperature drops, but it is not because of it being a metal. There is something else which is not in your syllabus right now. Fine. Now, molten mixture of aluminium oxide and cryolite is electrolyzed with graphite electrodes. That's it.
What's alumina? It's aluminium.
Alumina is pure aluminium oxide. Pure aluminium oxide is called alumina. So that's it. That's the final thing. I've given you 3 steps and I've given you reason for step 2. That is what they'll ask you in the exam. There's 3 steps and there's a reason for why we do step 2. And again, please memorize that we use graphite electrode. Underline it for you, graphite. Anything else?
And what's Na, sodium 3A, 1F6?
ALF6. ALF6, right? This is called trisodium aluminium hexafluoride. You have no clue about this, and you don't need to know this. Please write the equation in your notebook, and I'll write it separately right here as well. This is Na3AlF6,
So
and Al
right,
stands for aluminium. Yes.
right now you call it tri, right? This is what I was telling you in the last class, that our chemistry teacher told us to say tri.
Yes, but there's something else. The issue here is Al2O3 is not aluminium trioxide or tri-aluminium oxide. It's going to be dialuminium trioxide, right? Now I don't remember what you were saying, but Al is not 3 here. If it was 3, I would say tri-aluminium oxide. But this is called Al2O3 or aluminium 3 oxide, or aluminium 3 oxide. Now in this case, I have Na3. That's why I called it tri. It's 2 over here, it's 3. Does that make sense? Question answered. So if it's 3 after Al, then you can say tri. The Al2O3 is also, just leave that for now. Let's focus on this. Any questions? First write it all,
No,
then
sir.
we'll talk about this. We'll try to understand. There has to be at least 10 questions there in your minds. But you're saying, no, sir, I get that, that's okay. But finish writing, we look at questions, and then all the questions will come about.
So what is cryolite?
What is cryolite? Cryolite is, right over here. What is cryolite? Well, I'll tell you this afterwards, but cryolite, another ore of aluminium. Don't write this right now in your notebook. Write these 3 steps. There's more to it. There's another step which we have to finish. And then directly we'll go to the questions. Another ore of aluminium, aluminium oxide, used to reduce operating temperature of nitrogen. Now add this right here and save energy cost. Now, okay, quickly tell me, how much have all of you written? Diana, Lula, how much have you written? Zara,
I'm done, sir.
I finished writing.
finished. Safa,
Sir, I'm done. I'm just writing the definition of cryolite.
all right, write that as well. Fine. The rest of you write the definition of cryolite as well. Actually, don't write it right now. Who is writing it? Tell me.
I
Me.
finished.
Finished it? Okay. Then write it. No worries. Write it. Because there's more over here which we have to talk about. Now, in your notebook, write a few things. Over here, ore of bauxite has very high melting point, say of 2030 degrees Celsius. Let's just say 2000 degrees Celsius. Write this in your notebook. After ore bauxite, melting point of this much. Then lowers melting point to 900, 950 C. Now I've added two more things here. This part and this part. Add this to your answer in your notebook. Tell me when you're done.
Done, sir.
Finished? Now let's go downwards. Now we look at electrolysis. Or in step 3, we look at electrolysis equations. Or let's just say electrolysis. What you need to know is aluminium. Just write electrolysis equations. Aluminium is extracted at cathode. You know that. Equation for this is Al 3 plus liquid plus 3 electron gives us Al liquid. Write this properly. Now next thing we have is oxide ions are last thing at high temperature carbon electrodes react with oxygen gas to form carbon dioxide. Write everything as I am writing it, and okay. Final thing is this causes or this uh, um, causes the electrodes, the graphite electrodes, anodes, Finished writing? How much have you written? Guys, tell me.
Sir, I
Have you
finished.
finished everything from here?
Yes.
Yes. All right. Then the chapter is almost over. You look at questions now and you're done. Just write one last thing. The answer for this question is, why is aluminum extraction expensive? All right, just one last thing. Go to the top here and write in the over here in process. I just want you to add one thing here. Process. Write halt. Or don't write it. Never mind. Then, or write it actually. Halt herald. That's the name of the process. Fine. That's called halt herald process. HALT. Hall herald. Sorry. That's it. Now over here, all you have to do is the process needs a lot of energy. Replacing carbon anodes is expensive. It's expensive. Done. Now we'll start from the beginning. Tell me when you're done writing. I'm giving you information in an organized manner. If you read the book, it's like a paragraph, it's like a story, which does not make a lot of sense. But over here, everything is perhaps organized and there's nothing which will not come in the exam. Now, not all of this will come. Well, all of this will come, but some are more important than the others. Let's look at that in a second.
I'm done, sir.
Done. Now, okay,
Done, sir.
finished. Finished. Zara,
That's all.
okay. I'm getting a passport question for you. Just a second. Now, this is called skill check. This is the part of the class where we solve questions and try to understand how to apply the knowledge I gave you in your notebook. Now, Diana, read the question quick.
Which process is used to extract aluminium from bauxite? Heating bauxite in
Yeah.
air.
And
Heating.
Zara, read after this. Zara, continue.
Carbon, heating bauxite with hydrogen, passing electricity through purified bauxite.
Now, which of these do you think, Lula, is the correct option? Safa, which option do you think is correct? Lula, Safa, tell me. Answer. Now you have to choose options. It's a quiz. Whoever chooses it and it turns out to be correct will get 1 point. Zahra, Diana, Lula, Safa. Now usually Safa is on top. And so Zara said D. That's Zara's answer. Anyone else? Which of these are correct? Now I'll tell you then if you don't know, the answer is going to be, should I say?
Wait,
The
I
answer is
will
going to
say
be,
the. I will. I'll
just go
say
on, tell
C.
me the answer.
I choose D.
Okay, Diana chooses D. Safa? Safa, don't stay behind. Choose anything. Choose what you feel is correct. You'll choose
D.
D. All right, Safa chooses D. Therefore, D is the correct option. Because electricity, electrolysis, electricity, right? What is electrolysis? Electrolysis.
Compounds.
Breakdown of compound using, is it? Using electricity, right? See that word right there? That is what we're doing. We're doing electrolysis right here. Extraction aluminium, we use, it's electrolyzed. Where is it? Electrolytic cell, electrolyzed, no, where is it? Molten mixture of aluminium oxide and cryolite is electrolyzed. So electrolysis. The next thing we have to look at is something more difficult. Now, who gets marks here? So Zahra gets 2 marks for first answer. Diana and Safa get 1 mark. They'll get chances to catch up. No worries. All right, let's see. 6. Come on. Start reading. Someone, Safa, read the question.
Aluminium is a very strong and foreign metal. Aluminium is extracted from its ore by
Bauxite.
bauxite by electrolysis. Bauxite is an impure form of aluminium oxide, Al2O2. Describe how aluminium is extracted from bauxite. Include an ionic half equation for the reaction at each electrode.
At each electrode. All right. Now, how do we answer the question? Now, I have to use the options which we know already, right? There are 3 steps. Read the first step, Zara. What is the first step?
Bauxite is treated with sodium hydroxide to get pure aluminium oxide called alumina.
Okay, Lulan, read the next step.
Aluminium oxide, alumina, is dissolved in molten cryolite. This lowers melting point to 950 Celsius.
All right. Now, why do we do this? Because it saves energy cost. Diana, read.
Reason saves energy costs by lowering operating temperature of electrolytic cell.
Electrolytic cell. Now, if look, first thing first, I have this beaker. I'm going to put some ingredients here. The first ingredient was bauxite. Then I'll put some salt, not really salt. I'll put some NaOH, sodium hydroxide. So when I have bauxite in this, next step is sodium hydroxide, which is basically NaOH. Okay, sodium hydroxide. When I add this, now this turns into, look, this will turn into alumina. This gray thing, which is alumina. Now, what do I do after this in alumina? I'll add some other thing, which is called cryolite. Cryolite. All right, this is cryolite, and I add this. Then I'll get a new mixture, which is this, which will have alumina in it. It will also have some cryolite in it. Cryolite is, by the way, yellow, but in this case. Now, when I add cryolite, after this, I get this mixture of molten mixture of alumina, which I already had over here. and also added cryolites, alumina and cryolite. Now what we do to this is we add electrodes like this in it and connect the power supply. So plus minus, you can do this in your house as well actually. So you have plus minus. Now in this molten mixture I have Al3 plus and I have O2 minus. Now can you tell me where does, and both of these by the way are carbon electrons. Now quickly tell me, Diana, where will Al3 plus go, negative or positive electron, cathode or anode?
Can you repeat the question?
The question is, where will Al3 plus go, cathode or anode?
Cathode.
Cathode, because it's positive goes to negative. Zahara, where will O2 minus go?
Anode.
Anode. That is where what gets us to this final equation. Aluminium is extracted at cathode. We know that obviously, because aluminium goes to cathode, O2 minus goes there. So we get these two equations, equation 1, equation 2. Now these are the main equations. Very important. Fine, so aluminium is extracted at cathode, and while these equations actually we will call them half equations. Write this in your notebook. In front of this equation, try to write half EQ, half equation 1. Like this, half equation 1 and half equation 2. Tell me when you're done writing. Half equation 1, half equation 2. Finished?
Yes, sir.
Now let's go back to the question. If you look at the question, they're asking us half equations here as well. They're asking us half equation at anode, half equation at cathode. Now let's read the half equation at cathode. Luna, read the half equation at cathode.
Al3 plus liquid plus 3E minus equals
Electron
to
minus.
electron equals to aluminum liquid.
So we'll just put that here. For the cathode, we had Al3 plus 3 electron gives us Al liquid and Al liquid. Any questions?
No, sir.
Now next thing, half equation at anode. Safari, the half equation at anode.
2O2 minus, which gives 2O2 plus 4 minus.
4 electron. We'll write that right here. So we'll get 2O2 minus gives us O2 plus 4E minus. Any questions? We're just writing that here, anode cathode. Now this question is for 5 marks. 5 marks. So we got 1 mark for this, 1 mark for this. 3 marks are remaining. So we have to put 3 points here and 4 points. We first say how is it extracted. So we'll say bauxite treated. Just write it as steps here. Now you have to memorize the whole thing from what I've given you in notebook, but I'm writing the answer for you here. First step is aluminium or bauxite is treated with sodium hydroxide to get alumina. Next thing we do is second step. Alumina is dissolved in in molten cryolite to lower melting point to how much, Lula? Melting point to how much? Lula, tell me. Or Safa, Zahira, how much? Where does the melting point turn out? How much? 950?
950.
950 degrees
950.
Celsius.
Perfect. So from where? From 2000. So bauxite, well, let's just say 950. Let's say from 2000 C to 950. Okay. Now third step is molten aluminium or molten, this mixture, let's say this mixture is electrolyzed and molten aluminium is collected. At where? At where? Where is it collected? Collected. Cathode or anode? Anode? Molten aluminium is collected where?
At cathode.
Cathode. Yeah, so that's my 3 points. Okay, 3 points. First step, second step, third step. So these are 3 marks. That's 1 mark. Any questions? Any difficulty here?
No, sir.
Now, okay. Now read this part here. Why do anodes have to be replaced regularly? Read the question. Zahra, read the question.
Explain why the nodes have to be replaced regularly.
All right. Why does it have to happen? Why is that the case? Now look at this. Read this part. Diana.
At high temperatures, carbon electrodes react with oxygen gas to form carbon dioxide.
Okay. Then next part.
The carbon anodes slowly burn away and need to be frequently replaced.
Replaced. Not replaces, I'm so sorry. Replaced. Now please add one more line here in your notebook. After burn away, write in air. Not in air, write in oxygen. Sorry, oxygen. Tell me when you're done writing. Finished?
Yes, sir.
Yes, sir.
Now above this, just above this guy, write why anodes are replaced. Right, put a question mark here. Right, just above this answer. And write this as A answer. Why anodes are replaced? That's the answer to this question. This right here is the answer because the carbon anode slowly burn away in oxygen and need to be frequently replaced. Finish, or tell me when you're done writing.
I'm done, sir.
Let's go back here. Now, so someone tell me, why do the anodes have to be replaced regularly?
The carbon anode slowly burn away in oxygen and need to be frequently replaced.
Perfect. Slowly burn away in oxygen. Away in oxygen. So need to be replaced. Fine. That's 2 marks. Any questions? Any difficulty here?
No, sir.
No.
Now finally, well, whatever I gave you will always obviously come in the exam, right? I know what they'll ask in the exam. That is why I wrote all of that here. And they're asking the same things in the exam as well, right? So please go through it, revise everything. Now, last question. Lula, read the question.
Give 2 uses of aluminium and give a reason why aluminium is suitable for each use.
Each use. All right. Now this is chapter number 15, or I think 14 or 15, with alloys and metals. Please read the uses of aluminium metal quick. Lula, if you have the notes, or Diana, if you have the notes, or Zahra, Safa, read the uses of
what, sir?
aluminium and tell me. Uses of aluminium metal. Uses of aluminium metal.
It is used in kitchen utensils.
And
Also,
I don't
it's
think that's
also
the correct
used,
answer. Used for
also for airplane parts.
airplane parts. Exactly. So one answer is here. Airplane parts. Reason why is it used?
Because it makes the I don't remember, but I have two that I know. One, because it might not rust, and second, because it makes the airplane light. It's not heavy.
So low density.
Yes.
So that's 2 marks here. Done. Good job. Next one. What else? What else? You have aluminium foil, right?
Yes.
Now you must have written this in your notebook. The answers are hidden inside your notebook. So if you unlock your notebook and go deep inside your notebook, you'll find the answers. Aluminium foil. Or food container. Why is that? Now no one will answer. Well, you can answer in the chat. Whoever gives the reason first gets 2 points. And if you give the correct answer afterwards, still you'll get 1 point. In the chat. Zara, say the answer to me out loud. The rest in the chat. Why do we use aluminium foil or food container?
So the food stays hot at the same temperature. The temperature might lose 1 degree, but it will just stay hot if we use aluminum foil.
Stays hot.
Yeah.
Right. That's one reason. Anything else, Zara? Think. Anything else? Now I've gotten one answer so quick. It's actually it's perfect. I've got correct answer in the chat, but I need more answers from other people as well. So whoever has not given the answer, say, and Zahra, think again. Why would you use aluminium for food?
Sir, I don't think I have these notes.
You don't have them. Well, yeah, that's why it's important to be in the class when I'm teaching, because look, you can't learn any other way. You have to talk to me. Now you have, I think I'll send you the notes afterwards. Again, Diana, remind me in WhatsApp. Is that clear?
Okay.
Write them, and then writing them will not be enough actually. You'll have to speak with me afterwards. So I'll explain it to you also. Fine?
Okay, sir.
All right.
For the losing of moisture,
Lula, give the answer. Yes, Zara.
or losing the moisture, or the heat, or
No, it's not related to heat. Now tell me, Zahra, when we were doing alloys, why do we use stainless steel? The answer is less corrosion, less rusting.
but sir, how less roasting is done by aluminum foil?
But this does not apply on food rusting.
It does apply. It does apply. It only have two
Rusting?
options. You only have two options: less rusting or less corrosion, right? And lightweight. Those are the two properties of aluminium. What are the two properties? Right over here. Uses of aluminium. Or first, one thing is airplane body, which is low density. Next thing is food container. Why? Because low rest or less corrosion. Now, Safa, how did you get the correct answer? Tell me.
Because so we have like you tell us to write this.
You wrote this, right? So you have to check in your notes, and you must have written it. Now, okay, tell me. Ask Lula. You're asking about why corrosion related to food something. Ask me.
I was
Or
saying
Zara,
that
ask. Yeah, go on.
corrosion
Yeah.
or rusting doesn't apply on food since we use aluminum foil on food. or food containers.
Yeah, but would you eat something would you eat, let's say, if you take tiffin to school, right? Some tiffin or some food, sandwich, anything like that, and you put shatta on it or you put some sauce on it and it starts rusting. Will you eat it? Right? You will not
No.
eat it because it has rust on it. Iron easily rusts with water. Your food has water, right? Food has water. So that water will cause, or air, even air will cause rusting. So I don't want my food to have rust in it, which is poisonous, by the way. Therefore, food container must be low corrosion. Any
Okay,
questions?
for the food container, I understood, but the aluminum foil part, I didn't.
All right. Food container is aluminum foil. What is the job of aluminum foil? Tell me. Aluminum foil contains food, right?
To protect heat.
Now heat, right? That's a big thing. Everyone is saying to stop heat loss. That is correct, but that's a property of all metals, right? It's not specific to aluminum. Every metal will stop heat loss, or less, or let's say heat loss will not be there. So I can even use iron in that case. I can use copper, but aluminium is used because it does not rust, right? Less corrosion. Write this in your notebook. Due to protective aluminium oxide layer. I think you must remember this. Now write this in your notebook. Tell me when you're done. Heat, the point on heat is for all metals. It's not specific to aluminium. You have to say something which is specific only to aluminium. Finish writing?
So
Yes, sir.
Yes.
I'll just give you one question. Now, this is not related to aluminium or this class, but this is from last class. Read it and answer. So for this one, Safa, read the question. Quick. I think Safa read the last question. So Diana, read this one.
Which raw materials are used in the manufacture of iron? Bauxite, lime, bauxite and limestone, hematite and lime, hematite and limestone.
The answer. What do you think is the correct one for iron? First, tell me which option is wrong. What do you think is wrong? In MCQ, we have to first see which is wrong. So step one, what is wrong? Quick. What is the ore of iron?
Hematite?
Hematite. So bauxite is not the correct answer. Bauxite cannot be it. Bauxite was aluminium, right? Now, next one. What else do we use? Limestone or lime?
limestone, it's the correct limestone, I guess is the correct answer, yeah.
So limestone creates lime, or thermally decomposes to lime. Decomposes to lime, but it's not the raw material. Raw is what you're taking from the ground and earth. So decomposes to lime. We do use lime, but this thing makes lime, so that's why we use limestone. This is wrong. Finished? Any questions? I think that's it for now. Now, who's going to recap? Zahra, recap. What did we learn? Or what did we do in this class?
Okay, so we studied about electrolysis and some about bauxite and ore and the extraction of aluminium, and we have done some past paper questions. These are past paper
Diana,
questions.
anything else? Yeah, past paper questions. All of these are past paper. I only give you past paper questions. Diana, anything else? Recap.
I think that's all.
That's all. Lula, anything else?
No, I think that's all.
That's all. Rest prevention. Now, next, what are we doing next class? Safa.
Rest revision.
Rest prevention. Fine. That's all for now then. Take care. Goodbye. Khuda Hafiz. Allah Hafiz.
Goodbye. Allah Hafiz.
Thank you.
Allah Hafiz, sir.